Today we're going to conduct the experiment that proves Bernoullis theorem. This is the experimental setup, and first is the hydraulic bench, and on top of it is the Bernoullis apparatus. We'll also require a stopwatch to measure time. The first component of this setup is the flow meter. This flow meter will measure the flow meter, and over here we have a valve that allows the water to come in, and this controls the pump, turns it on and off. We have the water inlet that is connected with a union to a Bernoullis tube. The Bernoullis tube is connected with another union, and the water flows outside from the outlet over here in the back. We have a valve that controls the water outlet, and we have a hypodermic probe that you can see from the inside as well. Over here we have a manometer, and then we have an air outlet to control the air outlet, a valve. And in here we have a ball valve that allows the water to leave the entire system. The objective of this experiment is to investigate Bernoullis theorem using water flow, applied water flow in tapered ducts. So, to begin the experiment, we're going to first ensure that there is no water in the system. We are going to do that by opening the ball valve. So once the water leaves the system, we're going to also open the exit valve, and we're going to turn on our pump. We're going to make sure that all our manometers are level, and then once all the manometers are level, we're going to open the inlet valve and let water flow through the system. Once the water flows into the system, if there is any bubbles that are forming, we're going to allow it to exit using the air valve. We're going to be able to control the pressure inside the system using the exit valve by closing it or opening it. And the more we close it, the more the pressure increases. Once we have the water flowing through the system and that there is no air bubbles found here, we're going to turn off the water outlet from the system by closing the ball valve. And we're going to measure the flow meter, the flow rate. So using this flow meter, once the water reaches 1 liter, we're going to start the stopwatch and wait until it reaches 6 liters, so we can measure the flow rate based on 5 liters. Once we have the flow rate and the system is fixed and there are no constant changes, we can set the first manometer to a certain level by opening the pressure valve. So our given is 280, so we're going to change this to 280. And once we've fixed the first manometer, we're going to measure all the rest of them. The final manometer measures the total head of all the other manometers. Once we've measured all of the manometers, we're going to change the hydrodynamic pressure using the hypodermic probe. So we're going to open the connection over here and pull the probe perpendicular to the tubings. So once the tube is perpendicular to the first duct, we're going to notice there are some changes in this pressure, but the total head stays the same. So we're going to slowly pull it to be perpendicular to the second duct, and we're going to see some changes in the system, but the total pressure, total head should stay the same. So we're going to measure all of them every time we move it perpendicular to one of these ducts. And once we're done, we're just going to allow the water to leave the system by opening the ball valve. We're going to turn off the water inlet and let the water leave the system. You can then close this exit valve and turn off the power. That will be all. Thank you.